Right, well, welcome everybody. Welcome to the British Computer Society Enterprise Architecture Specialist Group. This evening, we're talking about blockchain architecture wars. And I'm delighted to introduce you to a very old friend of mine, John Wotherspoon, who's coming in from the US. I worked with John back in the mid-1990s. We were in a startup together in Virginia, and we lost touch, but regained touch. So it's great, actually, the power of LinkedIn to reconnect to people. John's currently working on a couple of projects that are going to get released later this summer. One is on decentralized finance, which is DeFi, and one is on authorization. And he calls himself an entrepreneur developing blockchain products. And he's agreed to speak this evening on this interesting subject of blockchain architecture wars, which has become actually more relevant in the last few weeks, given there's been a lot of news about Bitcoin and how much energy it's using. In the research I did just before, in 2019, Bitcoin was using as much energy as Switzerland, and more recently, as much energy as Belgium and New Zealand combined, and probably even since then it's gone up. So there are some real issues which I'm sure John will go into in his talk. He's going to spend about half an hour with his slides, and then we'll go into a Q&A, and the Q&A will be via the messaging chat platform. So if you have a question as we're going through, just put it into the chat, and then we'll pick it up at the end, and we'll go through and take the questions one at a time. So I think that's it. John, over to you, sir.
Great, thanks. Let me just jump right in. So hello, everybody. John Wotherspoon. I'm from Cuvia Labs. We're based here in the US. Lauren, thanks for inviting me to speak today. Today, we're going to have a high-level review of three of the prominent blockchains, Bitcoin, Ethereum, and Cardano. Now, I do want to state a little disclaimer here. Although that each of these blockchains has a crypto economic token associated with it, we're only going to focus on the architecture and the functional nature of the blockchain. Nothing we talk about today should be construed as financial advice or financial insights. I am not a financial advisor, and you should never take advice from me on finance. There's plenty of other people way more qualified than I am, and all you have to do is jump on YouTube and start subscribing. You'll get all the advice that you want. So for a little background on me and Cuvia, Cuvia Labs was founded in 2015 with the goal of supporting and advancing the crypto ecosystem. We're huge believers in decentralization. We have been from the beginning, but this space moves extremely fast with a lot of innovation coming in all the time. So to achieve our goals, we continually analyze blockchain functionality. We run nodes on multiple blockchains and blockchain protocols that seem to have something to offer in the space. There's a lot of filtering that has to go on in order to make sure that we can get focus and draw some value out of the work that we do. Right now, this is an estimate over 850 independent blockchain protocols operating, and more being launched all the time. So we do find that we have to focus on a handful of chains at a time and look at the ones that are going to allow us to build the products that we're trying to bring into this space. And then we work with the folks in those targeted communities and become part of those blockchain and protocol communities. Community involvement is very important if you want to get anything done in this area. So today we're going to chat about the basics of blockchain technology, and then try to map them back to those three prominent, or at least the recognized blockchains of Bitcoin, Ethereum, and Cardano. I think most people have heard of those. But before we dig into these, let's quickly level set our understanding of blockchains in general. If some of this seems a little bit basic, I do apologize. But I just want to build a little foundation before we jump into three particulars. So what's a blockchain? Fundamentally, a blockchain is a ledger of stored data on a network of computers. And all blockchains have three pillars of functionality in common that are unique to any processing environment that came before. So all blockchains are required to have these common properties of decentralization, transparency, and immutability. Now, some people take some liberties with the definition of these pillars. There's some gray area on how we put a box around these definitions, and that causes a lot of tension on the message boards when people are promoting or trying to release a blockchain. But I'll try to talk about what the pure definition is. So we'll start with decentralization as it relates to blockchain is twofold. The first thing it does is the data is recorded and stored on multiple devices in multiple locations. So it's scattered, preferably diversified around the world. So we don't end up with storage, even if there's a lot of it condensed into one region, because one region can be fairly controlled. Decentralization also means that no one person, company, or government or any other entity controls the data storage process. So if an enterprise, let's say IBM, comes in, and they release their blockchain hyperledger, and they said, we're decentralized. We have all these nodes. They're scattered all over the place. They're stored on different devices, but they still fall underneath one entity. So a lot of people argue, well, that's not really a blockchain. It's decentralized. So it's possibly something else. And you can think about that in the terms of banks, universities, corporations, governments controlling and managing data. They follow their own proprietary protocols. They decide where the servers are located, and they provide security underneath their own, their own guidance, which can lead to, and has led to in the past, many problems, from everything from stability to data theft and data loss. Now we can use blockchains to allow for decentralized record keeping, where data is recorded, stored, managed on a whole network of computers, all with open source software, and be able to achieve the same end goal that we have with centralized systems. And if changes are required on a blockchain protocol, we do go through a consensus process where we don't have one single entity to control how the blockchain works. We get consensus from the whole community. In this way, functionality is not being steered to the benefit of one entity or one organization. Any changes that are applied belong to the community. In traditional software environments, if Oracle was going to create a new release, they may not create a release that benefits the whole community. They may create one that benefits the economics of Oracle. Blockchains try to remove that by getting consensus from their community. Okay, we'll talk a little about transparency. Blockchain transparency relates to the way transactions are recorded and stored on a ledger. And the transactions on a blockchain are available for everyone to see. And that can sound like a scary concept. If I was to broadcast my bank ledger, would I necessarily want everybody to see every line item on my bank ledger? Probably not. So when we're creating blockchains, we have to be aware of what needs to be encrypted, what needs to be masked, versus what we need for the actual audit log. Now, these ledgers do provide a viewable audit log of every transaction And this is the good part, it makes it impossible to falsify. So I can't cook the books at all. So good or bad, that transaction is going to be visible on the ledger. We can talk about a couple of scenarios just so you can see, you know, the real world of use cases for transparency. A simple one is tax distribution, right? Everybody pays taxes. So citizens of most countries don't have a way of confirming how your tax dollars are collected or spent. We don't have any choice but to take the government's word that you know what they've spent the taxes on, how they've collected it, and where that money has gone. And even if a government came in and said, well, we're going to show you that, we'll open our books, it would be very easy for them to manipulate or change the data to suit their own needs, since they own the data. So you can see how this model it's not really truly transparent, and it does not encourage trust. There's always some skepticism on, you know, what's really going on behind the scenes with what we're putting, you know, with the money that we're paying. So now you kind of turn that around and you imagine if every citizen had the ability to see that live running ledger of where the money was coming in and where the money was going out. It would provide full disclosure of how the government's managing our money, and it would create institutional trust through transparency. When you're not afraid to show your ledgers, people tend to trust you. When you are afraid, people think you have something to hide. Okay, so now that's transparency. The third pillar is immutability. The premise of immutability is that the data on the blockchain can't be changed, it can't be forged, it can't be altered in any way. And to achieve this, we use cryptography on the blockchain and hashing processes. So any attempt to tamper with a block of data is discovered immediately by evaluating the hashes, and the block cannot be posted to the chain. So, and if I go in and I go into an existing ledger and try to modify a previous transaction, that is going to corrupt the hash. And again, it will invalidate, it'll invalidate any of the modifications to the chain. So those types of activities by bad actors are captured in real time. So summarize the pillars of a blockchain. Blockchain recording and storage protocols make sure that your data is verified, that it's unmodifiable, it's distributed across the vast number of computers around the world, incorruptible, and no one person or entity can control the data or the network. And this results in complete transparency. Now, if you're looking at an environment and you think it's a blockchain and it doesn't comply with these three pillars, you're probably not looking at a blockchain. If you're developing an application on a blockchain and you're not in compliance with these three pillars, or your concept isn't in compliance with the three pillars, you may want to consider a database instead of a blockchain. That's just our general rule of thumb. And I've evaluated a lot of potential projects where at the end of the evaluation, it was more appropriate to put that on a database rather than putting it on a blockchain. So at a high level, let's look at the Bitcoin, Ethereum, and Cardano blockchains, see how they work, so we can highlight some of the differences. We're going to review these in order that'll allow us to look at a progression of complexity, kind of like building blocks. We'll start with Bitcoin, simplest of the protocols. Then we'll move to Ethereum, and that's got the most variety and the most used protocol today. And then one of the youngest but very promising is Cardano. The most industry experts recognize that the current evolution of blockchain technology can be broken up into three different generations. Gen 1 focused on money transfer, simple movement of a store of value between two destinations with no middleman, right? Gen 1 handles like very, very simple transactions, no or very little conditional logic. Bitcoin tackled Gen 1 requirement nicely, and it serves its purpose as a strong point-to-point value of transfer. It's not super fast, but it is super secure, and fits nicely into that category. Gen 2, the next level, the next evolution, allowed for conditional logic, and this was in the form of smart contracts. If then else kind of things, external oracles, access control, signing, workflow, a whole range of functionality can be built into those smart contracts. And Ethereum filled that void as a leader, and they're joined by many smaller players who also have adopted a smart contract model and have their own versions of smart contracts. But Ethereum by far is the leader in that space. The smart contract enabled the creation of decentralized applications, and they're called Dapps. And that's one of the things that those are the projects that I work on now, is the creation of Dapps. The potential nature of Dapps was inspired by the decentralization of traditional business processes. So we looked at existing processes. We look at processes that have a middleman that maybe don't add a lot of value or could be replaced and codified. And those become very interesting targets for DApp development. And I mean, in the past, I've seen a lot of industries hit with this: supply chain, travel, healthcare. It's kind of the holy grail is people's healthcare records, but there's a lot of concern and worry about data privacy. But that's been a debate that's been going on for quite a while. But most recently and most impactful is the finance industry, and that's Lauren mentioned earlier. Decentralized finance or DeFi applications target removal of the middleman in financial arrangements and allow for point-to-point interaction in the finance workflow. And there's countless applications for that. Why cut out the middleman? Mostly because of unnecessary cost. So anytime we pass through a broker, you pay a broker fee. And if we can remove that broker, we remove that broker fee, and everything becomes more economical for the people who are actually using the service. The last generation is generation 3. It's the Gen 3 blockchains are plugging the holes that we have in the Gen 2 blockchains. So first hole we're looking at is scalability. That's speed, right? So how fast can transactions be processed? Bitcoin does about, and these are rough estimates, 4 transactions per second. Ethereum maybe 10 to 12. Cardano in its current state is quite slow. It's 7 TPS, but they're with their next release in the roadmap, and I'll probably repeat this a lot because it's really fascinating. But their milestone is next milestone is 1 million transactions per second, and that number will vary, but 1 million is really significant. So another hole that we have in Gen 2 is interoperability between chains. We're in an environment where everybody is working in a proprietary silo. And this is really a strange feeling for folks who've been doing traditional development in the past. We've got no clear leader has stepped out and said we are the protocol that should be followed. So what we've got are silos of development occurring and no way to interoperate between them. So think about if we didn't have one internet, we had 10,000 internets and everybody ran on their own little internet, but they couldn't talk to each other. That wouldn't be very useful. So if I go to Google something that's not on my little silo, I'm not going to be able to see it. So the same problem we're having with in the blockchain space is that interoperability. It's called IBC, interblockchain connectivity, and it's a hole. Now Cardano has IBC on their roadmap, so everybody's crossing fingers and hoping that we can achieve that, because without that IBC, we kind of have to piece together stuff that it's kind of a kludge to get that connectivity, to get tokens moved from one area to another, and there's large fees with that, so it makes it impractical. And the third hole is sustainability that Gen 3 is gonna target. So the ability to fund ongoing support. Now, one of the concepts that's being released with Gen 3 is the implementation of decentralized bank and a decentralized governance body that can evaluate a protocol's need or request for change, and through tokenomic economics have a reserve where they can help fund those changes. Traditionally, blockchains are funded at the front of the project through something similar to an ICO. And then once that ICO is over, that's all you have to work with. You have no other recourse. It's not like traditional software where I can go back to the VC and do multiple rounds, which there's positive sides to that, but the negative side to that is it puts a damper on what you're able to do from a future growth or future enhancement perspective. So it'll be nice to see Gen 3 come out with some kind of a governance that will help to keep some of these projects alive and more useful to the community. Okay, so and just on the Gen 3, Cardano will be considered Gen 3. Ethereum 2.0 will be considered Gen 3. So, and those are coming targeted for this year. So we're really hoping we get a lot of these problems resolved. All right, so let's jump into Bitcoin. Bitcoin, everybody should realize what a technical marvel Bitcoin is. So Bitcoin was launched in 2009. It's never been hacked. It's never been corrupted. It has zero downtime. It's been up 100% since 2009. All of this with no central organization providing any administration, no hosting fees, no support, no patches, no data recovery. This is a free-range chicken, and it's been up and running since 2009. I think we would be challenged to find a centralized enterprise platform that could make that same claim even for 6 months. So the fact that Bitcoin's been around that long and has never been corrupted is simply amazing. Now I know some of you are going to say, well, I hear about people losing their Bitcoin and all of that. That's outside the chain. Nobody's attacking the chain. Nobody's corrupting the chain. They're intercepting. They're phishing. They're attacking the exchanges, but never the blockchain. Okay, so Bitcoin, the token, it's a digital currency that people can use as a store of value, or as a store of payment that people can use to transfer to one another. The transfer is registered on the Bitcoin blockchain, and every transaction, no matter how small, has a corresponding record on the blockchain. So if I send you, if I send you from my wallet to your wallet, if I send you $10 worth of Bitcoin, that is going to show up on the ledger. And you recognize this pattern from the earlier generic slides, but the structure of Bitcoin is a network of computers running open source software. You can look at it; it's beautiful stuff that's installed on the computers. Each time a Bitcoin transaction occurs, the data is transferred through the network of computers. And the computers, so the computers that maintain that network are called nodes. So the nodes validate the transactions, they add the transactions to their individual copy of the ledger, and then they broadcast that ledger of changes to all the other computers in the network to be validated, and then once validated, added to the block. Each block is programmed for a maximum amount of data it can store. So that data, you can calculate the speed of the network based on that block of data, and that's why we look at about 10 minutes of validation time from the time that the block is posted onto the blockchain. So we've got this network, we've got a lot of computers, a lot of nodes validating blocks of Bitcoin data. So on their computers, so who are these people? Validating the transactions, and why the heck would they want to do this? It seems like it would take, a lot of effort. And so Bitcoin transactions are verified and broadcast through a process that we call mining. And the folks that are doing this are called miners. Miners are people with, they're either people or pools. Individuals will get together and form a pool of miners. And they have the Bitcoin software installed on them, and they do that work of validation. So the algorithms that are required are part of the Bitcoin software, and they use their computing power to run that validation. Maintaining the blockchain involves keeping the Bitcoin transaction ledger clean, consistent, and permanent by grouping all of the new transactions in the blocks and then publishing them out for the network to be posted onto the main net. For a new block to be accepted by the network, the miners they compete with each other using their own computing power. So everybody wants to have the latest and greatest, and they do this work, right? They do the work of verifying transactions, and in exchange for that, they get rewards. So the winners of this competition now have proof of work, right? I won, I came up with the answer, I solved the puzzle, I have the proof, so they're proof of work, and I'm going to receive the reward. Now, the algorithms for validation of the blocks are extremely intense. They involve comparing the hashes of the current block and comparing them with the hashes of the chain. And then they rehash and calculate the addition of the new block. And it's a race, right? And the guy with the fastest computer wins. So this is why, and Lauren alluded to this earlier, the cost of Bitcoin mining. That's where the cost is, right, in energy, is pretty high. So the miners go through a lot of expense. They spend a lot of money on computing power, and they spend a lot of money on energy to run their computers. It'd be very, very expensive. That cost is actually a security net. It's very, very expensive to capture the validation and corrupt the chain. It requiring controlling majority of the nodes. The only entity with that amount of resource to capture the Bitcoin blockchain, and it could be done if you pump enough money at it, but the only entity that could do that is a nation state. Would have the resources to do that. And even if they corrupted the chain, there's no financial gain at the end of it, just disruption, no reward. And on the energy side, and this is kind of recent hubbub about energy consumption in Bitcoin. Yes, it does take a lot of energy and computing resources, but so do traditional banks. I don't need a building with Bitcoin. I don't need people to drive into work. I don't need to, I don't have to support a whole infrastructure, even down to printing paper and printing money. I mean, if you add all of that stuff up and put it on a scale, that's probably greater than the energy produced by or consumed by Bitcoin. Again, my own. I don't have any explicit data to back that up, but that's kind of the way I see it. So the rewards for these miners, they're in place to incentivize the miners. You've got to give people compensation for doing that work. So you incentivize the miners to participate in the mining process to ensure the validity of the Bitcoin network. And those mining rewards are a combination of some newly minted coins and transaction fees based on existing circulating supply. That's one of the mechanisms for distributing Bitcoin, is using the mining rewards come from the uncirculated pile of Bitcoins, and that's how they insert the Bitcoins into the ecosystem. And that kind of brings us to token supply. So you can see that that reward structure is a combination of circulating and non-circulating rewards. And Bitcoin, a characteristic programmed into Bitcoin was a maximum number of tokens. So the total number of Bitcoins that can exist is 20. It's actually 21.5 million. And the original intent was to mirror the inflation rate, something similar to gold. So they created this 21.5 million. They held them in reserve, and they slowly trickled them out into the ecosystem. And it's kind of interesting if you think back to that mining metaphor. There's a lot of similarities, abstract similarities between Bitcoin and gold miners. Mining, looking to strike it rich. Well, Bitcoin was kind of designed to be that digital gold of sorts. The current supply, circulating supply, is 18.7 million. And they'll continue to release tokens through mining until all 21.5 are distributed. And then at that point, the reward for the miners, it gets less and less, but the value of the coin is more and more. So their net is increasing. But we'll switch to fully being rewarded based on transaction fees. And then the one of the advantages of implementing that maximum cap on any token is inflation. So once Bitcoin releases all of its 21 million, it'll be immune from inflation, and will be a pure supply and demand economy. So contrast this with fiat, where when we want to stimulate or suppress the economy, we print more money, and we use inflation as a control. Cryptocurrency, which is fairly unpredictable. You're at the mercy of whoever's printing the money. So any token economics that utilize a maximum token release is really trying to maximize on that benefit of supply and demand. Other ways of doing it are burning. So you can burn tokens too. So even if I release more, at least if I released 1 million more, I'd burn 1 million on the other side, but it still controls the total circulating supply. And I won't go too far into token economics on this, but I thought it was important to kind of see how the environment's fueled. All right, so we'll take a look at Ethereum. So Ethereum is very similar to Cardano in this lecture, in that they're both programmable blockchains, right? You can actually program functionality on this blockchain. You can build software, you can create products, and you can create services. Many people use Ethereum and Ether interchangeably when they're actually two different things. So Ether is the Ethereum network's native currency. So we've got Ethereum, and then the economics are driven by Ether. Now, Ether functions like Bitcoin in that it is a digital currency. It can be transferred, used for payment, or as a store of value. But its real purpose was designed to fuel the Ethereum network. We talked a little earlier about the distributed pillar of blockchains, where open source software is distributed across the network. While to incentivize people to host and maintain the data on the blockchain, Ether, it was created as a payment for the maintenance. So anyone developing an application on the Ethereum network is required to pay a transaction fee for the computing power and the space to fuel the network. And the amount of Ether required for network fees is defined by a built-in pricing system called gas. And that's built into the logic of the protocol that our application will sit on. And that calculation is defined as a bandwidth plus space plus computational difficulty will give you your gas fee. And then as you're processing a transaction, we know exactly what that gas fee is going to be. The problem is that it's also based on the current value of Ether, and can skyrocket. We're in a situation now with proof of work in Ethereum where transaction fees are extremely high. And sometimes your transaction fee is greater than the value that you're trying to transfer. so you come out negative on a transaction. So that does need to be addressed. Programmers watch that very closely right now because it can make or break a project. And then Ethereum or Ether is not fixed. There's no fixed supply. There can be as much as is needed. It's constantly created, no limit. But there's rumors, like really strong rumors, that Ethereum 2.0 is going to have mechanisms to control that supply. So it'll move us back more into kind of a supply and demand environment. So we'll see. Have to see what happens with 2.0. We can break Ethereum down into 3 basic layers. You got your hardware layer, you got your software layer, and you've got your application layer. The base layer of the software is just like as before with Bitcoin, is this network of computers called nodes, and the nodes are connected to the internet with software, open source software installed on them. You can see it, you can copy it, release it on your own blockchain. You have total visibility to it, so it's not doing anything nefarious. If you're worried about it, you look at it and you say, okay, what exactly is this doing? And you can see no hidden gems here. And then so as the nodes perform the computation required to process the data, they're rewarded with Ether based on the gas formula that we saw before. And these rewards motivate the maintenance of the Ethereum network. The more the miners are making, the more they're motivated to actually continue mining. One thing, so Ethereum does currently use a proof of work model similar to Bitcoin, and it's slow. One of the things, as I've been developing apps, certain Dapps, Ethereum was not an option because the user experience was just too slow. And that can be problematic. So especially if you're trying to create a UI where somebody is, submitting a transaction, you don't want them waiting around for forever to get proof that was actually added to the blockchain. So we've looked at other faster blockchains that use different mechanisms that aren't in that top 3 of Bitcoin, Ethereum, and Cardano. So the software, the transaction data can take the form of Ether and the form of code instructions, right? So the code on Ethereum network is represented in smart contracts. So you can imagine that second layer on top of the base layer of the network. The software layer supports programming languages and a programming language library, and they use Solidity, Viper, Bamboo, and a few others. Using the languages, developers write the smart contracts, and those smart contracts are just lines of code that dictate the terms and the control of the execution of the contract. Again, those are all visible. It's all open source. You can look at every smart contract and validate, debug, whatever, make suggestions. So it is all visible, just like any open source software. The combination of Ethereum's hardware layer and software layer, the smart contracts, create an environment for trusted execution of the smart contracts. Smart contracts they're autonomous, so it's really important to have a well thought out concept in Ethereum. Before you release a smart contract, you want to make sure that it is fully tested, because once you release it, it is autonomous and it sits on the mainnet. Or a side net that talks to the main net, if it is not accurate, you can cause some harm. You can cause people to lose transactions and a whole plethora of stuff. So smart contracts make the transactions. So all the transactions coming out of a smart contract are trackable and transparent and permanent. You can look at the smart contract. You can track the corresponding transactions that were processed through that smart contract. So we have the hardware and that software layer, and combined that creates this supercomputer, and that's known as the Ethereum virtual machine, or the EVM. The EVM's role is to create a level of flexibility and introduce some separation between the software host and the software applications, just like any any traditional VM works. And now the final layer of Ethereum is that application layer where the Dapps are located. So the application allows developers to build and launch decentralized third-party applications, or Dapps for short. And based on stats, these are fairly recent, stats collected from stateofthedapps.com. There are, and this is a testament to Ethereum, there are over 2,800 Dapps currently deployed on the Ethereum network, all with a varying degree of utilization. By far, the largest inventory of Dapps for any chain. So that's why I said earlier, Ethereum has a great community. It's reflected in the number of Dapps that they have on their network. If you want a detailed review, go to State of the Dapps, apply filters. You can look at other blockchains and kind of get a picture of it there. But these things are because it's so transparent, it's very easy to track these things. So we've got a lot of sources to find this kind of information. Now, if Ethereum stays on schedule, there should be a release of 2.0 in late 2021. I have confidence that they will release Ethereum 2.0. The question is when, only because we've been disappointed a couple times. They had, promised a release and then they pushed it back and promised it and pushed it back. But it's no small task. You've got this big community that's on the current version of Ethereum, and then the migration to 2.0, and the change from proof of work to proof of stake. How are these miners going to be impacted or compensated? It's there's a lot to deal with there. So I'm sure it'll happen. I hope it happens in 2021, but we shall see. So the motivation for the upgrade is to introduce efficiency. So remember all those holes I talked about in generation 2. This migration to Ethereum 2.0 should resolve some of those. And with any luck, it'll also address the cost of transactions on Ethereum, which is becoming a roadblock and needs to be redressed. Okay, so now let's have a chat about Cardano, the very well-known blockchain, but utilization is low. Some deployment on private blockchains. So I can't see Cardano. I can't see Dapps on a private blockchain. It's not transparent. Which means, is it really a blockchain? But Cardano is running. They've been done a lot of focus on private networks and on their roadmap this year. And I do trust their roadmap. We're looking at them releasing the next version, and then that'll make it very useful, especially in the DeFi space. So then we'll see an explosion of Dapps, I hope. Okay, so and when we look at, if we look at the list of blockchains, and if you talk to the experts about the ones that are most likely to exist in 10 years from now, besides Bitcoin, I think everybody agrees that Bitcoin will be around for quite a while. Cardano and Ethereum are at the top of that list. They're both trying to power decentralized finance. Ethereum has a stranglehold on it now, but Cardano has that as its targets, and it would be well suited if they can deliver what they're supposed to deliver. But their teams have taken like a very different approach. Cardano has been extremely cautious and meticulous about their approach for releasing functionality, while Ethereum has been using more of a monetizable version approach to releasing, opening up their software to development teams and letting the development teams just develop, and letting the valuable bits kind of rise to the top. And that's why we see so many Dapps. There are a lot of failed Dapps as well, but you see so many Dapps on Ethereum, and it's just this constant iteration. And from Cardano's perspective, because of their approach, not as many Dapps. Both projects have one thing in common: they have a very strong community. So their technical community is very strong. They both have a lot of adoption or concept adoption, and I think they're both well positioned to provide some great value. Again, especially if we can reduce the cost of fueling these networks. Both projects do have both Ethereum and Cardano have kind of a common ancestry. So Charles Hoskinson worked on Ethereum before he had a disagreement with Vitalik Buterin, and he went his own way. And then Cardano was born shortly after that. I'll let you guys, you guys can do some find a lot of stories and books on that relationship. It'll make for some great late night reading. So I encourage you to look at that. But that personal interaction between the two kind of formed this next most extremely powerful chain. Both these guys, Vitalik and Charles, brilliant. Just both of them are brilliant. So Cardano's one of the key features of their architecture, and this is part of what's going to give them the speed, is they're using a dual layer architecture. First layer is a settlement layer, and that's where all the records of the native transactions are going to occur. And the second one is that computational layer where the smart contracts are executed. So by separating those, they're able to get those massive speeds that we talked about. So that's one of their key the key foundational concepts in their next release. And then we did. I keep talking about speed only because it's just I'm blown away by it. But I've heard anywhere from 1 million transactions per second to 2.5 million transactions per second. And as a point of reference, so Visa currently processes 1,700 transactions per second. So you can see that's and they function quite nicely, right? So from a commerce perspective, Cardano will exceed the need for speed from that perspective. So, but other applications will certainly take advantage of that kind of speed. Ethereum, they are targeting 100,000 transactions per second after they migrate to 2.0. And even that obviously is going to exceed something that somebody like Visa needs. So Cardano is going to utilize a proof-of-stake mechanism for validation. So basically, I don't, just to define that, proof-of-stake concept states that a person can mine or validate transactions according to how many coins they hold. So if I can stake a larger number of coins, then I have more mining power, right? So this, or let's validation power. Now this can cause problems, right? Can someone corner the market? If they've accumulated more tokens, yeah, they can. And people are always worried about that. Where's the stake coming from? Who owns the stake? And at some point, if I can capture the majority of the blockchain, can I cause some harm? Now Cardano, within their model, they discourage large staking pools. So if a staking pool gets too large, there's financial implications to that. And they encourage then the generators of adding more stake to that staking pool. They spawn another smaller staking pool. So the idea is to have staking pools of similar size across the blockchain, and this way everybody has an even shot. For validating. It kind of levels the playing field so that you're not trying to battle against some big whale. A whale in this environment is just somebody who owns a large share of the tokens. Beautifully, Cardano is seeking to resolve that inter-blockchain connectivity issue that I talked about a little bit ago. They want to become the internet of blockchains, right? So they want to be able to through the Cardano blockchain, be able to interact with other blockchains and create bridges that are seamless. I can bridge right now. I'm working on a project on Telos, and I'm bridging to BNC, to Binance. I have to, I can use bridges. I'm manually building a bridge because no proper bridge occurs, and certainly not at the protocol level. So in that instance, we'll probably build our own bridge and try to avoid transaction fees. If Cardano can implement this bridging concept, you're just going to eliminate those blockchain silos, and we'll be able to build very complex dApps that can cross blockchains for best of purpose, right? Without going through an exchange and getting exchange fees and making it financially impractical to run. So, who's the winner here? I think everybody is. I think the blockchain ecosystem is going to be the biggest winner. I think right now, I don't think we're going to see we're not going to see Bitcoin go away. I don't think. And I don't think we're going to see Ethereum die or Cardano die. I think what's going to happen is the innovation is going to benefit all of the community, even the alt chains are going to be able to benefit from this competition that we're seeing here. Bitcoin's getting adoption now. I don't know if you guys saw what El Salvador has petitioned to use Bitcoin as legal tender. I think that happened yesterday. Yesterday or the day before, while I was in Miami for the blockchain 2021 conference, and it was announced there. Ethereum made some, they rushed to market, but they learned a lot from that, and they built an incredible community. I mean, there's Solidity developers all over the world at this point. So that's, community is extremely important. And Cardano, they held back. They identified the potholes from the Gen 2, and so they've got that advantage of observation. Their community is also rabidly strong, very committed. And the roadmap is they've delivered everything on their roadmap that they said they were going to do. So there's no reason to question, their delivery in the future. So Lauren, that's the end of my discussion.
Great, thanks, John, so much. That's fascinating, really fascinating. There are lots of questions, but I'm also conscious of time, because we said we'd try and complete in roughly the hour. And what's interesting is while you've been speaking, there's been a conversation, a distributed conversation going on about this 51% that you've talked about of mining work, and it seems to have resolved itself. So I'll let everybody follow that thread in the Q&A, and I won't cover a Q&A, but just one or two things. Do you have any examples of where this works, at scale in an organization, where the enterprise architecture specialist group, we're interested in, technology changes that are going to shift, quite a bit in terms of, how we manage information within organizations. Can you give one or two examples that we might, be able to look out for that
Sure.
will work with blockchain?
Yeah. So one of the things that I've realized is that in order to solve a business problem, you don't need to have a all-in blockchain solution to solve a business use case. If you look at the business use case, there are going to be certain pieces of that can gain value from a blockchain, and other pieces that just aren't appropriate for that. But it doesn't mean you have to discard either of those either a centralized or decentralized approach. One example is this whole idea of an audit trail. Blockchains are really great as a dual ledger in an environment where you have the blockchain simply as an audit of transactions, but you don't know what those transactions are. All you know is this transaction happened at this time. Here's my record of it, but I don't really need to know the details of that transaction. The details can be stored in a traditional centralized data store or alternate data store, right? So now I've got a mapping of the transaction up here, visible to everybody for audit purposes, but the link from that to my data store can be protected. So even though I see the transaction, there's maybe a hashed ID of that. That hashed ID is going to match down in some data store and have, you know, private information, maybe medical records, right, that you don't necessarily want to blast on a blockchain. So using blockchains and that kind of approach, if you kind of loosen your mind up a little bit and say what pieces of this would be valuable to have those three pillars, you know, for the community, and then isolate the functions there, and then everything else that kind of needs to be centralized, you know, keep it centralized. So I'm seeing a lot of hybrid use cases at this point, which a couple of years ago I didn't. It was all or nothing. It was either blockchain or not. So the non-blockchain guys hated blockchain, the blockchain guys loved it, and they didn't want hybrid. So
no, that's really good. And you were talking in terms of private blockchains and public blockchains. What do you predict there? Because obviously, you know, there's, as you said, if it's not transparent and public, then it's not a blockchain. But what's going on in that space?
Yeah, what's going on in that space? So private and permissioned blockchains limit who can have access to them, and they usually fall. Once you limit access, or you have the ability to limit access to something, then you've got an administrator. An administrator is a centralized figure. So a lot of the use cases I see, or I saw in the earlier days, they used private implementations of blockchain. So they had nodes, right? And they were validating the data that was the records that were going to be placed on the ledger. But I could do that in a database if I'm going to do it in a private way. What I don't have in that environment is security. So when you expose that validation, that mining, those nodes become publicly exposed, you get a lot of security built in, right? And also crypto economic security. So that whole like a GUI, like a gas on the Ethereum network, it makes sure you do a good job. If you don't, there's going to be financial penalty, right? You're going to lose your stake. If in a private blockchain, a lot of them don't have any crypto economics at all, so you lose that whole incentive-decentive layer of economy. And again, if you're going to do that, maybe a database is more appropriate. Hybrid, there you go. Now you can probably take that and create a decent solution.
Sure. No, interesting. But there's been one or two questions about why we chose Bitcoin, Ethereum, and Cardano. Are there any other sort of technologies or platforms, you know, particularly in the third generation space, that are worth noting?
Yeah, there are a lot. These are the basics. So they were probably, you know, they were a good target. But you could have a separate conversation on Algorand. Is a great platform. They have they've actually got a source of randomness that is becoming industry standard. So if you need to pick a random number, lottery kind of thing, they've got algorithms for randomness that are stellar. They're also being considered on a lot of DeFi projects because they have some internal bridging right now that they can bring to the table. I think the U.S. Treasury out of Boston is working with them now to come up with some sort of a digital asset that the Treasury can use. So Algorand's good. Fetch AI, very new. I encourage you guys to go read it. I don't, you know, I'm not an investor. I'm just fascinated by their technology at this point. Fetch AI creates, just like it sounds, they codify bots that are autonomous and self-learning. And there's use cases that have already been deployed. They have some applications that have been deployed in Berlin for maximizing parking space within the city of Berlin. There's a lot of implementations. They've got a solid team, and I can see a lot of use, possibilities for what they're offering. But Fetch AI, artificial intelligence, in the form of a very lightweight bot that runs on something as small as a Raspberry Pi.
Amazing, yeah. And we've had some questions about Hyperledger. Can you make a comment about that?
Hyperledger, private blockchain. The one thing I'll say about I've consulted on a few projects with Hyperledger. Interesting, centralized. So parts of it I look at and I go, maybe database. And even IBM's kind of backed away a little bit from Hyperledger. They were pushing it pretty heavily, and they backed away. So I don't know. I don't know what the future of Hyperledger would be in its current state. Yeah.
Okay.
Cool. I can't say much more about that. I haven't.
No, that's great. Yeah. And it was interesting, your reflection on the amount of energy used and the energy used in a bank, and comparing that. But downstream, obviously, Bitcoin's come under a lot of pressure recently, or a lot of news. Where do you see this whole energy thing go? Is this Ethereum 2, the generation 3, going to fix the environmental issues that we've traditionally seen with the early generations of blockchains, or is there something else going on?
Yeah, so the energy on Bitcoin, Bitcoin's got some flaws, and they could address their mining and their validation. Remember, this was released in 2009, and at the time, it seemed appropriate. But the energy consumption is worrisome. But I think what happens a lot of times, people will maybe they take that energy that Bitcoin uses and they assume all blockchains are having that same problem. I think if Bitcoin continues to be just a store of value, and used for large transactions, it's going to keep the transaction and therefore the mining, at a minimum. But my counterpoint to that is, real world banking probably uses a way more energy than Bitcoin would. So
if you had a crystal ball, John, last question, and you were looking at 10 years, say, 5 to 10 years, what impact do you think blockchain technology is going to have, on certain sectors? You mentioned financial services, travel, using these types of technologies.
Barring any lobbying and legislative roadblocks, I think you're going to see the removal of a lot of centralized brokers. You're going to look at it makes economic sense. If I spent the time programming and developing code that performed the function that the broker does, then I can remove the broker from the equation and therefore reduce the cost of that transaction. So in 5 to 10 years, insurance is going to look different. You're going to have you're still going to have your traditional insurance companies, but I believe there's going to be options for people who want alternative insurance opportunities. Banking, the unbanked in the world is a huge problem at this point. I think that we're going to see DeFi provide options and alternatives for the current unbanked. I mean, you in the UK, me in the US, we don't think about it that much, but in emerging countries, you don't have banks. You can't get a loan for a car. You can't, you don't have any of those services. We take it for granted, but we're a minority. So I do believe that DeFi is going to ease a lot of that pain, and it'll be fairly common. And I think probably over the next couple of years, you're going to see a lot more adoption and acceptance of blockchain technology. It's, you had Silk Road, everybody thought, oh, Bitcoin, that's for buying drugs, right? In the early days, and that was a big, that was a big shouting point. Those arguments have gone away. The current one is the energy thing, but I think if once people analyze that, we'll get around that. But adoption, I think it'll become commonplace to utilize blockchain appropriately.
Brilliant. Well, thank you so much, John. I think we'll draw it to a close there because we're just slightly over time. But thank you. It was a fascinating talk. I'm sure we could have you back for 2 or 3 more sessions to go deeper. But,
sure.
But just for the moment, it was a great run through the sort of the evolution of blockchain and how it might get applied. And I think the thing I took away most was that this sort of whole world of hybrid is emerging. So it's actually going to be quite difficult to separate out the blockchain components from projects from other components. And yeah, it's sort of horses for courses, isn't it? So thank you so much.
Okay, great.
And,
thanks for having me.
Lots
everybody.
of clapping going on in the audience.
Very good, very good. Well, thank you so much, everyone. This was
okay.
Fun. All right.
Great. We'll catch up soon. Thanks, John, so much. Okay. Bye.